A2 Further Maths, Simplex Algorithm. Okay, using your skills from year one, what I'd like you to do, please, is just have a go, see if you can solve that linear programming problem and solve it using a graphical method. Okay, so pause there, take your time with it, see if you can figure out the appropriate equations or inequalities, and then have a go at plotting it on some squared paper. If you want to wait till I've got the inequalities before you sketch it, that'll be fine, and then I'll give you an opportunity just to check those inequalities first of all. Okay, so just pause there. Okay, so let's see how you got on with the inequalities. So the inequalities I would probably recognise first of all is if you have a look, it says each pair, just going through the actual equations, factory makes jackets, standard and super. So the number of jackets, standard jackets could be X, the number of super jackets could be Y, just to save us, and it says that here. X standard jackets and Y super jackets. So using that, factory uses a cutter machine and a sew machine, so these might be something that's constraining us. A pair of standard jacket could take 8 minutes on the cutting machine and 8 minutes on the sewing machine. Super jackets take 15 minutes on the cutting machine, 10 minutes on the sewing machine, but you are constrained with how long you can use each of the machines on any given day. So what we need to do now is use these three parts just here to see if we can form some equations. Now the equations or the inequalities you should definitely get straight away should be that you can't make a negative number of jackets. So we know that X is always going to be greater than 0 and that Y is always going to be greater than 0 as well. And the way we should always look at this, doing this as well, is not bringing any other letters in, not bringing any other sort of variables into it. We should only be using X and Y's. So what's my constraint? Well, my constraint will be to do with how long I can use this cutting machine. I can only use it for 12 hours a day. Now these are talking about minutes, so the first thing I'm going to do is just think about 12 hours as 720 minutes. And if I've got 720 minutes, I'll be using 8 minutes for every X and 15 minutes on that cutting machine for every Y. So the first inequality I've got, apart from the two obvious ones, would be 8 minutes for every standard jacket on the cutting machine plus 15 minutes for every time I use a super jacket, and I'm constrained because I have to use it less than 720. Same idea with the sewing machine. 8 minutes for every X, 10 minutes for every Y, but I'm constrained by 10 hours, which will be 600 minutes. There we go. Now these are our constraints. We're constrained by the fact we can't make negatives, and we're constrained by the fact that there's only a certain time limit on the two jackets. So we call those our constraints. Our profit function is this bit just here. This is what we're going to try to maximise. We're maximising the profit. So we get £3.50 for every X, £6 for every Y. And so I could write that as my profit is going to equal 3.5x plus 6y. You don't need the p equals. You could have that as an expression. That would be fine. But that's called our objective function. That's what we're going to try to maximise, or in some cases you might want to minimise that. Right, so again, you might want to pause there. Now you've checked those inequalities and that profit function, and see if you can sketch it. Just to help you out with your graph paper, that's the sort of graph paper you should be drawing in your books. Using those, you could have figured it out yourself. Hopefully you could have done that yourself. Have a go at drawing it out and then see if you remember how to actually solve it graphically. So again, pause there before I do it for you. Okay, so hopefully you started by sketching the two obvious inequalities. So X is greater than 0 means that you can't have anything negative, so I shade the bits you can't use. Y is greater than 0, shade the bit you can't use just there. But then we've got these two inequalities. 8x plus 15y is less than 720. So an easy way to do it is setting something like x equal to 0, find out what the y value is, y equals 0, find out what the x value equals, plot 2 points, draw your line. And you could find any 2 points that satisfy that equation if it was equal to 720. So any 2 points you like. You should not stumble with sketching straight lines at this stage. So think about 2 points that work, draw your line in. So there we go. There's a straight line just there, and we shade this part because any point on this side, for example 70 for x, 50 for y will definitely not work in that inequality. Okay, another option would be setting 0, 0. 0, 0 is definitely less than 720. So this side is the bit we want, so we shade the bit we reject. Same with this one. Divide, set x equals 0, therefore y equals 60. Set x equals 0, y equals 0, get your x value, plot it in, sketch it through. Again, 0, 0, I'll put it in there, definitely less than 600, so 0, 0 is on the correct side of that line, so I shade the incorrect part. And that is what I call my feasible region just there. Any point in there works for these constraints, so anything. Now, if I want to maximize this profit function, you've got two choices. You could do a vertex check. In other words, check in each of these vertices on the corner to find which one gets you the maximum profit. All right, that'll save you having to draw any lines. So check each of these. You have to figure them out. So this one here, you have to figure out by working these two out simultaneously. This one here, you can see looks like 75, 0, so you can put that in there. This one here, which is a bit more messy because it's going to be the one that was 720 over 15, so you got that one there, and so on. You could check each of these points. And once you've done that, the one that gets the highest profit is going to be your maximum profit. The other option that you need to know how to do is drawing an objective line. Now you can do that by setting this profit as anything you like. Doesn't matter what you choose. Okay, you want to choose something that probably could sketch onto your graph neatly. You don't want something so small it's down here or something so big it's up here. You want to pick something that sort of works nicely, like let's say 300, and therefore you could sketch that in 350, 700, something like that, so that it actually fits nicely on your graph. All right, so there's my example. I picked 210 because that nicely goes into both of those. So there we go. I sketched that line. Now what I know is that any value that I set here should get a parallel line. So to maximize it, what I'm going to do is I'm going to raise that line as high as possible. So you get your ruler, put it along that line, and your goal is to keep moving it till it's about to leave the feasible region. And you can see it leaves just there at that point. Okay, and you can see it's a bit messy. 45 it looks like, and then maybe this value here, 20 point something. So how do you figure that out? You solve them simultaneously. There's your answer, 45, 24. So how do you maximize your profit? You would make 45 x's and 24 y's. Put that into there. That will get you a maximum profit of £301.50. You're not going to get any better profit than that. So that's all your year one skills. Changing from a linear program problem, using the inequalities, sketching it and solving it graphically. So everything you've just done then should have been practiced in year one. What we want to do is look at how to solve it using what's called a simplex Tableau method. Right, grab your notebooks then. A simplex algorithm, instead of using a graphical method, uses an algebraic, a numerical technique. So I'm going to solve it, and the first thing we're going to do is just set up what we call a table, a Tableau. And before we can do that though, before we can set up the table, we need to change from inequalities to equations. So we want to show how to set up a linear programming question into the table, but first of all we need to change each of the inequalities you get into equations. And just a couple of facts on there. Setting up a simplex table, we first change the objective function to be maximized into an equation. I set it to 0 and it must be maximized. The simplex algorithm only works for maximizing problems. We'll discuss some minimizing problems later. Most of the time you'll be faced with maximizing problems. Okay, right, so if I look at that equation just there, first thing I need to do is just rearrange that, set it equal to 0. So it's very straightforward. I can take 3.5x on this side, I can take the 6y on this side, keep the p as positive, makes it equal to 0. There we go, done. And the reason for that is what your goal is to put all the variables on one side and the numbers on the other. The constraints, right, are inequalities. So we can change those. We can change those into what we call equations using a select variable. So take this one for example. 8x plus 15y is less than or equal to 720. Now if you imagine that 8x plus 15y could equal any number you like, less than 720. So for example, it could equal 700. It's 20 less than 720. So I could add another value to this side that takes up the slack. So if 8x plus 15y equals 700, the extra slack would be 20 to make it equal to 720. So I could write it like this: 8x plus 15y, that can equal anything you like less than 720, plus this extra variable, right? It's made it extra complicated by adding this extra variable, will always make up the difference to 720. If 8x plus 15y equals 720, s is 0, and as you know, the x and the y can't be negative, so the s value at most would be 720 itself. Okay, so that s is somewhere between 0 and 720 to make up the slack. Now you can do the same with this equation, but this slack will be a different variable to that one. So I'd have to use another letter. We generally use T. S for slack, then T, and then U, V, and so on. All right. The other two, x is greater than 0, y is greater than 0, are standard. They have to be that to use a simplex algorithm. Okay. Right. So simplex algorithm works for all variables, but not slack variables must not be negative. Okay. So we know that x is greater than 0, y is greater than 0, s is going to be greater than 0, and t is going to be greater than 0. Okay. Right. So pause there. Get down whatever the notes you need. Okay, so now we've actually got these equations set up like that. Notice that you've got all the variables on one side, values on the other side. We can now set up our simplex tableau. And the simplex tableau goes like this. Right, along the top is going to be all the different variables. So we're going to put the p, as we can see that. We're going to have an x and a y, as we can see that. We're going to have an s and a t. So we can definitely put those in. All right, so the p, the x, the y, the s, the t, they're our variables. This bit here is the value, whatever value it equal to. So we call that just v. Okay, so that's the number. Sometimes this line can be made darker because this is a definite separation. This is an equals part just here. Okay, these are the variables. That's the value you get the other side. Once you've got that, we can actually put these equations in now. Notice there's 3 rows for the 3 equations. So that first equation has to be on the top line. Doesn't matter about the other two, but the objective function must always be at the top line. So my p, I've got 1p there, so I can put a 1 in that bit just here. Okay. I've got minus 3.5x, so I can put that in there. I've got minus 6y's, so I can put it there. I've got no s's, I've got no t's, and the value is equal to 0. So if I read this out, I can see I've got 1p minus 3.5x minus 6y equals 0. Okay. I can also put the other two in. Right, this one's got no p's, so I'll put that in. It's got 8 x's, it's got 15 y's, it's got 1 s, it's got no t's, but it equals 720. And then the bottom line has got no p's, 8 x's, 10 y's, no s's, 1 t equals 600. So I've basically just changed the equations into this table format like this. Okay, once you've done that, what you're going to be doing is you're going to be working downwards. So I should have said this earlier. If you've written anything under your table, unfortunately it's going to get in the way. You might want to just draw the table further down from there. Okay, so that's our setting up done. What we want to do now is we want to manipulate this table. We could do that by taking rows away from each other. And we'll talk about what the goal is in a minute, but we're taking away rows from each other, so each time we need to add an extra 3 rows to our table. Right. The aim is like it says here. We want the top row to have no negative values. So at the moment, it's definitely not going to work because we've got a minus 3.5 there and a minus 6 here. So it's not going to work. What I need to do then is I need to do what we call an iteration. Because it's not optimal yet, because it's not got all positives on the top line, I'll have to do another iteration. So I'm going to do that by first of all choosing one of the things that's causing a problem. It doesn't matter which one you pick. Sometimes in a question you're told which one to pick, but if you do have a choice, it's probably a good idea to pick the biggest negative number. So the -6 is bigger than the -3.5 from a negative point of view. So therefore I'm going to pick that. That tells you which column you're working with. So I'm working with this column. This is my pivot column that I'm going to work with. Right, so what I do now is I need to decide what's going to be what we call our pivot. So now we've decided which column we're working on, we need to know which number out of these two is going to be our important one. And so what we do to decide the pivot row is a very simple formula, but it's easy to forget. You do what's called a ratio test. And the ratio test you get by dividing the V value by the number in the pivot column. So I'm going to do 720 divided by 15 and get a value. I'm going to do 600 divided by 10 and get a value. And that's going to be what we call a ratio test. Important fact there, you ignore if there's any zeros or negatives in this. So we don't do the 0 divided by -6, we ignore that completely. Okay, so we ignore anything that's 0 or negative. Right, because sometimes these will be negatives as well, you just ignore them if that's the case. Right, so let's go back, look at the ratio test. So 720 divided by 15, 600 divided by 10. So there's the first one, that got us 48. 600 divided by 10, that gets us 60. And I pick the smaller out of those two. All right, so this is the smaller out of the two. So this will be my pivot row just here. So once I've decided on my pivot row and my pivot column, that value there is the important one. That tells you what is your pivot. Okay, so 15 is our pivot. It's important to know the pivot because that's the one we're going to be working with. Okay, so what I'm going to do is I'm going to add an extra column in. Again, I apologise if I didn't give you space, but that's our equation column. Now to start with, this is just going to be nice and simple. It's just equations 1, 2 and 3. Okay. Later on, we're actually going to put a proper equation in here, so it helps us figure out. So at the moment, we've just got equations 1, 2 and 3, but later on you're going to be filling more of this in, so give yourself enough space. Okay, so I'm going to add an extra 3 rows, and I'm going to try forming from that one into our next 3. And I'm going to start with this pivot column. So these are equations 1, 2 and 3, so these equations will be 4, 5 and 6. Okay, but how do I figure out 4, 5 and 6? That's what I'm going to be doing now. Okay, so I'm going to start with this pivot row. The reason why I'm picking that middle one is because it's exactly the same position as this one. This is why it's important that the top row of each iteration is all to do with the profit function. Okay, so this top row is the new important one. This was our pivot row, and the first thing I need to do is once I've decided what that pivot was, that's the one I change to number 1. Okay, the others are going to go to 0. But how do I get 15 to 1 first of all? I need to do my normal row, my original row, and I just divide it by 15. 15 divided by 15, 1. Don't do take away 14. It's all about multiplication and division. Okay, so now, if I know that I'm divided by 15 to get from 15 to 1, I must do that with every single one of these results. Remember, this was an equation. And if you had an equation and you divided both sides by 15, the equation is still correct. All right, so I'm not changing the equation because I'm dividing up both sides, this and this side, by 15. So what do I get? 0 divided by 15, 0. 8 divided by 15, just write it as 8/15. Okay, you can leave the fractions they are. 1 divided by 15, 1/15, 0. And this one we know because it was from the ratio test, 48. Okay, now next goal is to get these two to 0 because it's all about the pivot column. So that goes to 1, these two are going to go to 0. Now how do I get those to 0 using this new row just here, this row 5? Well, what I'm going to do is to get the -6 to 0, I will have to add 6 lots of this column to this. Remember, if you're converting from one of these to a new one, you use multiplication and division. If you are using this row to cancel the other ones out, you are using addition and subtraction. So how do I get that to 0? I will do row number 1 plus 6 lots of my pivot row. It's all about using your pivot row. Right, so this is where it gets a bit complicated because I'm going to have to go through and I'm going to have to start using this formula. So how do I get this number just here? I use that number because it's number 1 plus 6 lots of this number. So 1 plus 6 lots of 0 is going to be 1. Okay, minus 3.5 plus 6 lots of 8/15. Use your calculator. Don't try to do the fractions in your head. You get minus 3 over 10. Minus 6 plus 6 lots of 1 is 0. That's what you wanted. 0 plus 6 lots of 1/15 is going to be 2/5, or 6/15 is fine. 0 plus 6 lots of 0 is 0. 0 plus 6 lots of 48, 288. So there we go. I've done the top row. And now that equation is exactly the same as this equation. It's just been manipulated, but it's exactly the same. There's nothing wrong with it at all. Same with the bottom row. So how do I get this? Notice you see a pattern. That's 1, 2. This is going to be number 3. How do I get 10 to 0? I'll have to do 10 take away 10 lots of the pivot row. Okay, so minus 10 lots of pivot row. And the sort of patterns you will see is these numbers here, 6, 15, 10, are the same as that pivot column. The numbers at the end, 5 and 5, should be the same. You're always taking away that pivot row or adding the bits to the pivot row. And these numbers should be 1, 2, and 3. So look for the patterns. Okay, some people just use the patterns to formulate the equations rather than trying to think too hard about it. Right, so what do I do then? That row minus 10 lots of this row. So 0 minus 10 lots of 0 is 0. Okay, 8 minus 10 lots of 8/15, 8/3. Remember, use your calculator. 10 minus 10 lots of 1, 0. 0 minus 10 lots of 1/15, minus 2/3. 1 minus 10 lots of 0 is 1. And this one here is 600 take away 10 lots of 48 will be 120. So there we go. I've filled in the next iteration. I've got a new set of equations. Have I finished yet? No. So we haven't finished. The reason why we haven't finished is that new top line, our pivot column, is still not optimal. It's only optimal when we have no negatives in it. Notice this negative value here is stopping it being optimal, so I've got to go again. Same idea, same algorithm, just got to follow it through. Be careful with your fractions. Okay, so let's go through. What did we do? Well, now we've got this negative in the top row, that tells us what our pivot column is. So we know our pivot column now is going to be that one just there. How do I figure out what the pivot row is? I do the ratio test. I'm going to do the 48 divided by 8/15. Get an answer to that. I do 120 divided by 8/3. I get an answer to that. I pick the smaller out of the two, so it's this one just here, and that will tell us what our pivot row is. Where they cross over will be our pivot. So we've got our pivot now. This is the one I want to reduce to 1. Yes, I filled in 7, 8, 9. This is what I want to reduce to 1. These two I can fill in straight away if I want to 0. That's my new goal. Right, so take this pivot row first of all. How do I get 8/3 to 1? Might seem a little bit more complicated before, but how do you get 8/3 to 1? You can multiply by 3/8 or divide by 8/3. Either way around would be fine. Okay, so I divide by 8/3, get your calculator, 0 divided by 8/3, 8/3 divided by 8/3, 0 divided by 8/3, minus 2/3 divided by 8/3, fill it in, and so on. So here we go, 0, 0, 0. That one divided by 8/3 is minus a quarter. 1 divided by 8/3 is 3/8, and 120 divided by 8/3 is 45. So I've done my pivot row. I now use that pivot row to reduce these two numbers, the pivot column, down to 0. So take this top column, this top row, sorry. What am I going to do for that top row? Well, equation 7 is exactly the same as equation 4. I'll see this pattern, 4, 5, and 6. So it's exactly the same as equation 4. I'll get that to 0. Plus 3/10 of this number just here. Right? Noticing it's the opposite to that. How do I get from minus 3/10 to 0? I would have to add 3/10 of that. Now I know the formula. Take your time. It's that number plus 3/10 of that number. 1 plus 3/10 of 0 is 1. 0 plus 3/10 of 0 is 0. 2/5 plus 3/10 of minus a quarter, 13/40. Alright, just go with what your calculator says. 0 plus 3/10 of 3/8, 9/80. 288, because that's row 4, remember, so 288 plus 3/10 of 45, 301.5. Okay, should recognise that number. Once I've done that, I can move on to this row. This is going to be row 8. We know we're trying to get this to 0. It's going to equal row 5 minus, because it's the opposite of this, 8/15. We want to get rid. How do we get rid of 8/15? We minus 8/15. Now I've got my equation set up. I can just go through 0 minus 8/15 is 0. 8/15 is done. 1 minus 8/15 is 0 is 1. 1/15 minus 8/15 of minus a quarter. So there's lots of fractions going on, but your calculator can handle it. Take your time. 1/5. 0 minus 8/15 is 3/8. Minus 15 minus a fifth. And then 48 minus 8/15 of 45 gets you 24. So once you've done this and set it all up, we have now finished. Noticing that top line is now optimal. And so because it's optimal, because it's all positive, I can stop and I can get my answers. So the question is now, how do you get your answers from that table? Now the reason why it's optimal is if I put it back as the equations, that top line is going to look like this. 1p plus 3/40 of s plus 9/80 of t equals 301.5. Okay. My other equations are going to be y plus minus plus a fifth s minus a fifth t equals 24. Remember, this is just a value. Don't write 24v. And the same with the bottom line. Put that in. So I know how to read from a table back to the equations. But how do these help me? Well, let's take our top line. That top line is, going back to what our goal is to maximize this p-value. Okay. And if I rearrange this profit line like this, so profit equals £301.50. Take away some amount of s, take away some amount of t. Now, if you're trying to maximize that p-value, and you can choose whatever s and t values you like, all right, these are variables. Okay, so these can equal anything greater than 0. Remember, they can't be negative. At greater than or equal to 0. What values would you pick to maximize £301.50? Now, if you imagine that you set s or t to equal anything other than 0, you're automatically taking something away from your profit. You want £301.50 in your pocket. You don't want to take anything away at all. So this equation here, and the reason why we want everything positive is because it'll rearrange to negatives there, tells you that to maximize it, both s and t have to equal 0. So the s value and t value would equal 0. Just be wary, sometimes s and t aren't equal to 0. Some of the x and the y values might be equal to 0. It could be any of the variables. In this case, it's just the s and the t though. So we know that if s and t equals 0, let's go to the other equations. So this equation just here is y plus some amount of s take away some amount of t equals 24. But s and t are 0. So these two can be ignored. Tells you that y equals 24. Same with the bottom line. S and t are 0. We know that from our profit function. So therefore x equals 45. And as you can see, you already knew these answers from our graphical method. Right, we got these values just here. So you could ask the question, well, why didn't I just stick with the graphical method? Now the graphical method is really good for 2 variables. But the moment you have 3 variables, x, y, and z, you can't use the graphical method because you can't plot the graph in 3D. Right, not very easily anyway. So this really only works, or this equation works, or the Simplex Tableau, for multiple variables, not just 2. Okay, you only know how to do the graphical method for 2 dimensions. Right, so well done if you managed to follow all that. Pause there just to take any notes.